Surface chemistry. Types of adsorption. Adsorption is one of the main and basic surface phenomena. Adsorption is found to occur in many natural, physical, biological, and chemical systems. It is widely used in laboratory research and industrial applications. First is the reversible and irreversible adsorption. The adsorption is reversible if the adsorbent can be easily removed from the surface of the adsorbent by physical methods. It is called irreversible if the adsorbent cannot be removed from the surface of the adsorbent. A gas adsorbed on a solid surface can be completely removed in vacuum. It is therefore a reversible adsorption. Examples of irreversible adsorption are adsorption of oxygen on tungsten adsorbate. Factors affecting adsorption. First factor is nature of the adsorbent and adsorbate. The amount of the gas adsorbed depends upon the nature of the adsorbent and the gas which is to be adsorbed. Easily liquefiable gases are adsorbed more readily than the permanent gases. Next is the surface area of the adsorbent. The extent of adsorption of gases by solids depends upon the exposed surface area of the adsorbent. Larger the surface area of the adsorbent, the larger will be the extent of adsorption under given conditions of temperature and pressure. Next is the partial pressure of the gas in the gas phase. For a given gas and a given adsorbent, the extent of adsorption depends on the pressure of the gas. Adsorption of a gas is followed by a decrease of pressure. And the last one is effect of temperature. For a given adsorbate and an adsorbent, the extent of adsorption depends upon the temperature. Therefore, according to Le Chatelier's principle, the decrease in temperature will increase the adsorption and vice versa. Adsorption of gases in solids. When a gas comes into contact with a solid, part of it adsorbs in the surface. Adsorption is mainly of two types: physical adsorption or physisorption, chemical adsorption or chemisorption. if the physical forces of attraction hold the gas molecules to the solid, the adsorption is known as physisorption or physical adsorption. If the chemical forces hold the gas molecules to the surface of the adsorbent, the adsorption is known as chemisorption or chemical adsorption. The figure represents the adsorption of gas molecules on the surface of adsorbent. This is the adsorbent and that is the solid surface. Gas molecules are adsorbed on the surface. That is, it acts as adsorbate. Physisorption and chemisorption. This figure represents a case of physisorption and this one chemisorption. In physisorption, every gas is adsorbed to a lesser or greater extent on all solid surfaces. But in this case, a gas will be chemisorbed on such solids only which it can combine chemically. That is a case of chemisorption. Differences between physisorption and chemisorption. In physisorption, the adsorbate molecules are held to the surface of an adsorbent by weak van der Waals forces. But in chemisorption, the adsorbate molecules are held to the surface of the adsorbent by chemical bonds. Physisorption is generally non-specific in nature. That is, it does not depend on the nature of the adsorbate and adsorbent. But chemisorption is highly specific in nature. That is, it largely depends on the nature of the adsorbate and adsorbent. Low enthalpy of adsorption in case of physisorption, that is about 20 to 40 kilojoule per mole. But in chemisorption, enthalpy of adsorption is high, 80 to 240 kilojoule per mole. Physisorption is favorable at low temperature. That is, it decreases with increase of temperature. But chemisorption is favorable at high temperature. It increases with increase in temperature. No appreciable activation energy is needed in case of physisorption. But in case of chemisorption, high activation energy is needed. In physisorption, multi-layers may be formed, but in chemisorption, only monolayers or unilayers may be formed. Physisorption is a general phenomenon and is found in all instances. but chemisorption is not very general in nature. Physisorption is a function of coverage of surface. That is, greater the surface area of adsorbent, the greater the magnitude of adsorption. But chemisorption occurs at fixed sites on the surface of the adsorbent. These are termed as active centers.